So welcome back again to my official YouTube channel Summits and Classes. In the last lecture we have understood about the concept of mirror formula, okay? And this day we are going to understand a very special topic again, and that is the nature of light, okay? Generally the nature of light is described in different theories, okay, and there were four theories that were most appropriate, and they plays a very important role in defining the nature of light. And these four theories are: first one is Newton's corpuscular theory, and the second one is wave theory of light, the third one is electromagnetic theory, and the fourth one is quantum theory of light, okay. You should also understand that the Newton's corpuscular theory was given by Sir Isaac Newton in 1675, and then wave theory was given in 1676, again in 1873, after 98 years perhaps, again 198 years, that was in 1873. The electromagnetic theory was given by Maxwell, okay. This was that Maxwell who has given the right hand rule related to magnetic field. In that you have studied that generally whenever we just expand the right hand fingers, including thumb, middle finger and the forefinger, then the thumb tells the direction of electric current. No, this rule was given by Maxwell, and that Maxwell was given what? Electromagnetic theory of light in 1873, okay. So we'll study about that. And then in 1905, that means 1905, Max Planck was given a very special theory related to light, and that was quantum theory of light, okay. So we'll study about these all contents in this session, and we will understand about the nature of light, okay. So we don't have to waste our time, and we have to start. So firstly we just have to understand what is actually the nature of light. Then try to understand the nature has the light has dual nature. The first nature is of particles, and the second one is of wave, okay. The nature of particle was firstly described by Sir Isaac Newton, and the nature of wave was firstly described by Heisen, okay, or that is also called Huygens, okay. Then for the very first theory, that was what? Newton's corpuscular theory, was given in 1675, okay. Firstly we just have to understand about that. Newton has told the very first thing about light, that light is produced from a luminous body in the form of tiny small particles, and these particles are called corpusculars, okay. So the second thing that was given by Newton was that these small particles, that means corpuscles, always travels in a straight line. You also have understood about rectilinear propagation of light, and that you have understood that the light travels in a straight line. No, this second point denotes that these corpuscles travels in a straight line. Also you have to understand these corpuscles, that means these tiny particles are elastic in nature. Elastic understands for whenever it is thrown on a plane, then by making the same angle it comes back into its direction. No, as you have understood in reflection of light, and whenever light falls upon a plane surface, then it comes back into its direction by making the same angle with the normal, okay. This states that the light travels in a straight line, okay. Also you can understand it practically by putting some boards, no, and you have to burn a candle there in front of these four cardboards, no, and after making a hole, that is called pinhole, after making a hole you can observe from the other side that the light is going, and you can observe that the light is coming in that direction. It states that the light is traveling in the straight line. Okay, generally the light is produced from a candle in this form. You can see here that the light is producing in a straight line. Okay, it is going in the straight line. Do you understand? So these two facts were firstly given by Newton. What? The first thing was that the light is produced from luminous body in the form of tiny particles, and these particles are corpuscles. Okay. The second thing was what? These corpuscles always travels in a straight line. Okay. And the third thing was really the most important thing in Newton's corpuscular theory. Okay. Or it is also Newton's particle theory. Okay. The third thing is very important. This states that the speed of light in denser medium is more than the speed of light in rarer medium. You also have to understand that this third concept or this third statement was wrong, and that was moderated further in wave theory of light. Okay, so try to understand only that Newton has said the velocity of light in denser medium is higher than the velocity of light in the rarer medium. Okay, this was the third thing or the third statement given by Newton's corpuscular theory. Okay, and the fourth thing that Newton has given, that the light travels in a straight line, and this is called rectilinear propagation of light. Okay, by the help of Newton's particle theory or Newton's corpuscular theory, generally the phenomena of reflection of light and refraction of light are described easily. Okay, and but after some time, after 1 year, Heisen has arrived. No, already you have understood about Newton's particle theory, these four statements. Okay, and now we are going to discuss about Heisen's wave theory. Okay, so in that we will just understand which things are given by Heisen's wave theory. Okay, so let us start. We are going to understand about the concept of wave theory of light. As you know, this theory was given in 1676. No, by Heisen or Heisen. Okay, this is also called Huygens. So according to this theory, these three statements were given. Okay, the first statement was that the light is produced in the form of wave. Why? Because he told that whenever this at the time of daytime, whenever the sunlight comes in a room, then it spreads in every direction. It means the light is not going in a straight line only, but it goes in every direction. That's why he told that the very first statement as the light travels in the form of wave. Okay, the second thing that was given by wave theory was that the light requires a medium to travel. Okay, he told that the light can't travel into vacuum, but actually what is that? The light also travels in vacuum. You know that? Because the light doesn't require a medium to travel. It was described further as well. No, but he was successful in explaining the second statement. Okay, because on that time generally a ether theory was there, and according to that the scientists we are assuming on that time that there is a ether in universe as well. In the universe, in the space, there is ether present, and that's why the sunlight travels from that to the earth. Okay, so he told that generally in space as well the ether is present, that's why the sunlight comes on the earth. Okay, so he was successful on that time to explain about the second point, and that is the light requires medium to travel. Okay, but further it was wrong. And third point given by wave theory is that the light travels with a higher speed in the rarer medium. No, and that means third theory was that, or the third statement was that the light having the higher speed in rarer medium and the lesser speed in the denser medium. What? The light having much velocity than denser medium in rarer medium. Do you understand that? Means if the light is traveling in air and water, then in the comparison of both the things, the light having the higher velocity in air and the lesser velocity in water. Okay, and this was the right statement. Okay, so these three things were given by wave theory. In that, the second point was wrong, and that point is what? The light requires a medium to travel. Okay, so these things were given by what? Wave theory of light in 1676. Now the next thing is to understand is what? Electromagnetic theory of light. So now we will discuss about electromagnetic theory of light. Let us start that. So as I have told you earlier, that electromagnetic theory of light was given by Maxwell. Okay, so Maxwell has told these four things about light. Okay, the very first thing he told that the light is electromagnetic in nature. He assumed that the light has both the natures. No, the first one is the nature of particles and the nature of waves as well, but he just supported more the wave theory of light. Okay, and he was succeed in explaining the phenomena of transverse nature of light. Okay, how? I'm just explaining that. So the first thing was that what? The light is electromagnetic in nature. Okay, and the second thing that was given by electromagnetic theory of light was that the light doesn't require a medium to travel. That was the right thing. You, as you know, in the wave theory of light, Heisen has told that the light requires a medium to travel. Okay, but in electromagnetic theory of light, this thing was completely moderated, and Maxwell has told at very first time that the light doesn't require a medium to travel. It can travel in vacuum as well. Okay, so you understand that the light can travel in any medium. Okay, the light doesn't require that there should definitely be a medium. Okay, it can travel in both of the things, in air, water, or vacuum as well. Okay, that means light can travel in a medium or without a medium. Do you understand? Okay, so the second thing was what? The light doesn't require a medium to travel. Okay, the third thing that was given by Maxwell was that the light having both electric and magnetic field. As you know, this is what? Electromagnetic theory of light. No, that means light having what? Electric field as well as magnetic field. This was the third point given by Maxwell. Okay, and the fourth point that was given by Maxwell was that the electric field lines and the magnetic field lines are perpendicular to each other, like as you can see in this figure, that what? In the direction of wave, the electric field and the magnetic field are being perpendicular to each other. As you can draw the what? Perpendicular lines between the electric and magnetic field, you can say that the electric field and magnetic field both are perpendicular to each other. No, and he has told that the light is transverse in nature. Okay, so these four concepts, 4 points were given by nature of light, and he has moderated the wave theory of light and told at very first time that the light doesn't require a medium to travel. It can travel in any medium. Okay. Now the next thing was what? The quantum theory of light. As I have told you earlier, that the quantum theory of light was given by Max Planck. Okay. So I just wanted to tell you one thing as well, that the lecture is going to be completed. No, so this was the last theory, and just understood simply things about it, because there is a special physics about quantum theory, though. Okay, and that is quantum physics. So I would not like discuss more and more things about quantum theory of light, but some important points, to only 2 points I would like to tell you. Okay, so the very first thing by quantum theory was what? The first thing was that he has told that the light is produced from a body in the form of energy packets. Okay, and these energy packets are what? Photons. Okay, these energy packets are? These are photons or quantas. Okay, as you know, this is quantas, that means quantum theory. This is related directly to it. No, quanta generally stands for energy packets of light. Okay, and the second thing was that the energy of these particles is directly proportional to vibration. Okay, that means the more time the particles vibrate, the energy be increased as well. Okay, and he has given a very important formula, that was E is equal to hv. What? E is equal to hv. As I have told you that E is directly proportional to what? Vibration. Okay, or the frequency. No, so E is directly proportional to F, we can let as well. No, or V you can let. So E is directly proportional to F, and you just remove the proportionality sign, then you have to put a what? Constant here, and that constant will be HF. So this was what? E is equal to HF. You can also write it E is directly proportional to V, or E will be equal to of HV. So this was the formula that was given by Planck. Okay, so these were the whole things that were discussed about the nature of light. So in the what is the conclusion of this discussion? I just wanted to tell you that at very last, in the what? In the quantum theory of light, it was assumed that light having both the nature, and it is also the reality, that the light having both the nature of wave and the nature of particles. Okay, so our discussion is being completed today here, and I hope you all have understood these all things. I have explained it in a very simple way. Okay, if you are just do not understanding any point, then try to watch it again and again, and it might be very much helpful in your further classes as well. You are studying this in class 10th, but these all concepts might really be helpful in your further classes in 11th and 12th as well. There is a special chapter related to light, that is the nature of light, in class 11th you have to study, and also about light in optics in class 12th you have to understand about these whole things. So these whole things were very much important, and you have to care about these whole things. I hope you all have enjoyed this lecture as well, and I would just like to say you all that this is the time of pandemic. Just put the mask over your face whenever you are going outside. Okay, so thank you for today. See you soon in the next class with a new chapter in mathematics, and that is linear equation in two variables. We will discuss about that thing. Okay, so thank you for today.